Welcome. Good morning, good afternoon, and good evening for the people who are joining in. This is the part 9 of our webinar series related to OPCUA FX. We have been covering different topics in and around OPCUA FX in this webinar series as part of the OPCUA FX professional LinkedIn group. You can join the group and get notifications on upcoming webinars and other interesting topics, and you can have access to all the different posts and other resources in and around OPC UA and OPC FX. So I'm Chatrapathi, and I work at Uttunga. I've been in this industry for about a couple of decades now, and I've been working on different communication technologies throughout my career. I represent Uttunga at OPCUA Foundation and other industrial connectivity related consortiums as well. Okay, we'll get into it. So for those who are joining for the first time, this is just a high-level overview of OPC UA FX. So OPC UA FX is a technology with extensions on top of the existing OPC UA standards and communication technologies and information technologies. So it's a kind of natural extension of where it allows the OPCUA technology to work at OT layer into a little more deeply between different devices and controllers and other OT infrastructure. And accordingly, the specification has been extended to support different physical layers, and at the top, different profiles have been defined so that different instrumentations can be utilized these profiles and extend their functionality to support OPCUA FX. So this is the core communication model within OPCUA FX. So it allows you to have standardized communication between controller to controller, between controller to devices, and even device to devices, and as well as it allows you to exchange data with the different compute platforms that are part of the OT infrastructure as well. There are several different use cases in which each of these communication channel can be utilized to meet specific requirement of these use cases. For example, when it comes to controller to compute, the data can be consumed by different compute platforms, different dashboard applications, asset performance monitoring applications, or any predictive maintenance and analytics applications, and so on. Similarly, controller to controller, it promotes interoperability and information exchange between machines from different vendors, and so different machines and subsystems can seamlessly exchange standardized information using OPCUA FX. Similarly, controller to device and compute to compute, device to compute, all these channels serve their purpose for meeting specific use cases. So today we'll talk more about efficiency and flexibility in manufacturing. What are the key aspects of efficiency and flexibility, and what are the different challenges that are currently faced to to improve efficiency or to have a very flexible manufacturing process or systems. And then how OPC UA and OPC FX based technologies can help in resolving some of these challenges to some extent, and then help to improve both the efficiency and as well as flexibility in manufacturing. And also we will look at potential use cases on how these specific use cases can be met by using OPCUA and UAFX based technologies. So if we look at efficiency in manufacturing processes, so there are several key aspects. So process improvements, resource optimization, quality control, time management, and energy efficiency. Of course, there are several other factors. At least in my understanding, these are some of the key aspects. So when it comes to process improvement, so streamlining the production process to eliminate any bottlenecks and to have a smooth and enhanced workflow uh, helps in efficiently running the manufacturing process. And resource optimization, this is again to efficiently use the different raw materials to reduce the wastage of raw materials, and energy management, as well as reduction of labor costs and other things are part of the resource optimization. And quality control, this obviously reduces any kind of rework and production time losses, and any other defect management activities also can be reduced if you have a much better quality control as well. And then the time management. So a very good time management reduces production times through much effective scheduling of the processes, and minimizes the potential unwanted downtimes. And then energy efficiency. So this implements implementing practices and different technologies that can reduce the energy consumption is a key aspect of achieving overall efficiency. So why efficiency is important? Of course, even though it is obvious, still there are few key aspects in which it is really important. First one is it reduces the overall cost. So overall operational costs and resource usages will be reduced, and having an efficient manufacturing system increases productivity, meaning high outputs in less time. So this will meet different types of customer demands more effectively. And quality improvement is important because to have a consistent and high quality products, because of which you will have much reduction in defects and returns. And then sustainability, of course, based on different process optimizations, and then the resource optimization and being energy efficient. All of this contributes to your sustainability goals, and overall it gives you competitive advantage as well. So there are different challenges in making a manufacturing process or plant efficient. So we are looking at some of these challenges here. So technological integrations and data management. Um, maintenance and unwanted or unexpected downtimes, and meeting some of the regulatory compliances and labor shortages, or in a way skilled labor shortages. These are several different challenges. So when it comes to technological integration, so any implementation and integration of advanced automation solutions, it can be costly and complex, especially when they are composed of components from different vendors. Like if you are looking at a production line, there can be machineries from different vendors. Each machinery may be built with controllers from different vendors, and they may be using different communication standards to exchange the data within the machine, and then to get the data out of the machine, and to have a synchronized communication between multiple machines. It becomes really challenging because they may use different data models and different communication standards. You often end up creating some customized solutions to map the data between these different machines and controllers and components because of the way they are designed and structured. So this becomes a challenge in achieving efficiency. And then the second one is data management. So in the industry, the amount of data is huge. So analyzing and managing these large volumes of data, that too again from various sources, it can be really challenging, especially when the data is modeled differently from each source, and then when you are trying to gather the data at a higher level, and then when it is from different sources modeled differently, so you'll be ending up doing some kind of translations or mapping, and throughout this process the data loses some of the context as it propagates through different automation layers. So this is a challenge. So quality of the data, and as well as being able to understand and analyze large volumes of data that is structured differently. So this is again another challenge. And then maintenance and downtimes. So unplanned equipment failures, when not detected early on or well in advance, can cause downtimes, and there can be other maintenance requirements for the equipment as well. And then when it comes to regulatory compliances, manufacturers must comply with a wide range of regulations. So, and these regulations may vary region to region, and based on the industry, there may be different regulations for each of the domain in which you are providing or you are manufacturing products, and shipping them to different regions. So this also again a really a big challenge. So so ensuring compliance overall is a very time consuming and costly affair, and this is also a key challenge for maintaining overall efficiency. And then the labor shortage. So there's a significant skill gap in the manufacturing workforce. So it's very difficult to find qualified workers, and this can lead to lower productivity overall, and then can increase training costs and training durations, and then by the time they are ready to be productive again, there can be changes in terms of the labor itself, looking for different opportunities, and then all of this becomes a strong bottleneck to maintain efficiency throughout the manufacturing process. So we can look at a high level how some of these challenges can be addressed by adopting OPC UA and OPC FX based technologies for each of these challenges. So for the first one, technological integration related aspects. So OPCUA and UAFX provides very easy to integrate solutions for information exchange between different automation systems. So these can be different machines and subsystems, and systems can exchange information seamlessly between themselves, and as well as with the rest of the automation layers. And so the integration of this technology is very easy. It utilizes a lot of existing network infrastructure, security infrastructure, and so on. So any Ethernet based networks can be very easily converted to OPC FX based networks. For majority of the applications, it serves the purpose. So because of this, the overall difficulties in integrating technologies can be easily solved. And then related to data management, so when you have different data sources where the data is modeled differently, and then the data is exchanged using different communication protocols, and at certain layer you would want to have a unified access to the to all of the data, where you need to know the context of the data as well in which it has been captured. More than data, you would need a rich information. So this is where a lot of work has been already done by OPCUA Foundation, its members, and several different other organizations as well in standardizing information models for several different applications. So there are several different information models which has been already defined for specific use cases. For example, for packing machines, there is an information model. For rubber machines, there are information models, and so on. And in addition to these, there are information models which would allow you to have a standardized mapping from any of the existing communication protocols as well. And there are information models which will allow you to integrate this gathered information into the upper automation layers, cloud applications, and so on. So with this, the information models are standardized for several domains, specific applications, and then specific devices, and so on. So this enables access to standardized information model from various sources and this makes it much easier to manage the data, and as well as analyze the data and feed the data to specific applications related to either condition monitoring or predictive maintenance, and so on. And then the next one is related to maintenance and downtime. So here we can have predictive maintenance applications, but again, having that rich information with its context in real time makes the difference on how these predictive maintenance applications can function more efficiently and detect specific changes in the way the equipment is behaving, and warn the users early on so that they can reduce the overall downtime. And without predictive maintenance, there are several crude ways of handling this. So they would have a fixed lifetime for specific equipment, and then uh, with with a fixed buffer well in advance before that specific lifetime goes away, they would be replaced. And compared to that, having a predictive maintenance application telling you, detecting it and telling you will be much more cost effective, and you can get the maximum output from that equipment before it actually requires a maintenance or replacement. So, and then related to regulatory compliances. So, based on all the comprehensive data collection capabilities of OPCUA and OPCUA FX technologies, so it becomes very easy in terms of traceability throughout the production process. So, having the capability to trace each and every unit that has been produced throughout the production process makes it easy to compliant against any regulatory compliances. So OPCUA and OPCUA FX together ensures secure and standardized information exchange that is usable for maintaining regulatory compliances. And there are several other regulatory compliances as well related to security. And for example, in EU, the Cyber Resilience Act is going to come into effect soon. So the OPCA communication standard with its security framework is already aligned to the Cyber Resilience Act to a maximum extent, and whatever the differences are there, that are also going to be addressed soon. And then the labor shortages or skilled labor shortages. So this is again a problem that can be solved with mm, solved by integrating more automation solutions and remote monitoring solutions. So OPCA and UFX supports remote process monitoring and condition monitoring, diagnostics, through its very rich information models and real-time information exchange. So this allows workers to manage multiple systems from centralized locations, and it overall increases the overall productivity with few workers, and it enhances the ability to manage all these operations remotely very efficiently. So, if we look at potential use cases on what specific applications and where OPCA and OPCA FX based technologies can improve efficiency and how they will work, we can look at these three examples: automotive manufacturing, pharmaceuticals, and food and beverages production. So when it comes to automotive manufacturing, there can be different components of production line, like robotic arms, conveyor controllers, quality checking sensors, and different um, devices and welding machines and so on. They can be from different vendors. So different vendors have a strong capability to provide machinery and equipment for specific application. So based on that, the end customer would prefer to have the freedom to choose these specific equipment, but still he should be able to have a unified uh, access to the rich information that this equipment can provide to do the automations and so on. Um, so streamlining communication and then the information exchange between all of these components of the production line improves overall coordination between different stages of the manufacturing, and it improves the overall speed of the production. And uh, with the different condition monitoring applications that can consume the real-time data provided by OPCUA and UFX technologies can reduce the overall errors and downtimes. And then similarly, when we look at pharmaceutical manufacturing, so they may want to uh, enhance their process so that it becomes easy for them to meet different regulatory compliances. So implementing OPCUA and OPCFX to ensure data exchange between various stages of drug production without losing the context and the rich information that is gathered at the OT layer is possible. So this with this information, uh, it improves the traceability and overall quality control of the items that are being produced, and we can achieve this with OPCA and OPCA FX without any unwanted data processing, translations, and mappings, and so on. So that becomes much easier to provide data which is required for meeting compliances. So, and for the food and beverage production, so they may want to optimize the overall process to reduce wastage. So deploying OPCA FX based technologies to integrate different sensors and control systems across production line will solve this issue, because this enables any real-time adjustments to maintain overall production uh, quality, and as well as the production scheduling, so that this will reduce the overall wastage. And also the continuous monitoring of quality control information and error information shared with the rest of the system in real time, that could lead to detecting any potential issues and make any necessary adjustments in real time on the run. So uh, this will uh, enable the food and beverage production to have much less wastage overall. Um, and any real-time information that comes from the OT layer to the upper layers will help in making decisions to reduce the overall wastage. So far we have looked at efficiency. Now we will look at it from the flexibility perspective. Again, related to flexibility, there are a few key aspects in which the overall manufacturing process or plant needs to be flexible. So we will look at some of those are some of the key factors. Mm. So first one is products. So uh, and then this is basically the ability to produce different variants of products, and then volumes, and then the flexibility in the process itself, and flexibility in routing, and flexibility in terms of energy integration and consumption. So when it comes to products, the plant or the production line should be flexible enough to produce variety of products using the same equipment with minor variations to the process. So this includes switching between different product types or models of the same product with minimal reconfiguration of the production line. So achieving that is flexibility from products perspective. When it comes to volumes, the capability or capacity to scale production up or down based on the demand fluctuations, and also this ensures uh, that manufacturers can meet different varying customer needs without overproducing or underproducing. And again, during the upscaling or downscaling, optimizing overall energy consumptions and resource consumption, and how much percentage of the production line are being used. So from all these perspective, making it flexible is important. And when it comes to process, so this is again process flexibility means you should be able to modify the production process to accommodate any new technologies or different materials or different methods. So this will allow manufacturers to stay current with what is happening in terms of the demand and supply of the raw materials, or the material science changes or advancements that are happening in the material science, or the other raw materials, and as well as any process advancements that are happening in process related technologies. To stay current to these aspects, you should have a flexible process where it can be changed or adjusted dynamically with minimal effort. And routing. So in my view, to some extent, the volumes and routing are a little bit related. So routing is where the production line should use alternative production routes or paths to produce a specific unit, or to do the manufacturing tasks. So this will help in managing any disruptions in the supply chain management, or also help us in reducing the or optimizing the resource usages, and also it will help them uh, to adapt based on the volume demand, whether upscaling or downscaling. And then the flexibility from the energy perspective. So with all the sustainability related pressure that is being put on the manufacturing sector, so the ability to use multiple diversified energy sources to complete manufacturing tasks is a is a requirement for these manufacturing companies. So the production line or the manufacturing process should have the ability to adapt dynamically for different sources of energy based on the energy demand, energy prices, and then carbon cost of the energy source based on where you are getting your energy. Uh, for example, if you have a specific time during a specific time of the day during which you would get more sustainable energy, then you would want to use that source, and then when that is not available, you may want to switch back to the conventional energy source, and so on. So that kind of flexibility should be there. uh, so this helps in meeting different sustainability goals as well for the manufacturing facilities and companies. So why flexibility is important? What are the key benefits that the uh, end users will get, or the end users in the sense uh, the manufacturing companies would get? So one is it would allow them to have an increased adaptability to any kind of market changes. So, based on how the market is changing, they can quickly respond to adapt to as per the demands, or per adapt to customer preferences, or any seasonal trends. And they can still be competitive in the market. And then any customization and personalization that may be preferred by the end users and the customers can be very easily accommodated if you have the flexible manufacturing process without uh, putting too much pressure on the cost point for the end user. Of course, when you have a rigid process, and if you want to accommodate for customization, so that's going to put a cost pressure on the overall unit price, and then customers would have to bear it, and as well as the timelines. So having a much flexible manufacturing allow you to meet the customer timelines, or quick timelines, even when there is a lot of customization is involved in the manufacturing process. So of course that increases the overall customer satisfaction and loyalty for the specific brand. And then you can reduce the overall lead time based on when you adjust the production process based on specific demands. And it also improves overall cost efficiency as well. uh, because of the flexibility, you don't need to spend too much on extensive retooling or setup changes and so on, and it reduces the wastage as well. So overall, you will be much more cost effective if you have a flexible uh, manufacturing process or plant. And also it encourages to be more innovative, and you will have the opportunity to have a continuous improvement of the overall process and setup. So if it is very rigid, even a minor change or a minor improvement, or replacing a specific equipment with a modern version of it becomes challenging. But with the flexibility, it becomes easy for you to have that continuous evolving and continuous improvement in the overall process. And then it also allows you to mitigate different types of risks. So any kind of disruptions such as supply chain issues or the natural calamities or pandemics or whatever it is, with the flexibility you will be still able to maintain certain degree of production continuously, and it enables you to meet any sustainability goals as well, because you will be using materials and energy and other things much more efficiently and flexibly. So what are the different challenges that are there in the manufacturing industry to create or maintain a much more flexible manufacturing process or manufacturing plant? So we'll look at some of the key challenges. So equipment and infrastructure limitations, different cost constraints, and so the varying demands of the customers in terms of new features or different uh, customizations and so on. And then uh, skill gaps in the workers, and as well as uh, different different disruptions in the energy sources. So there are several different energy sources, and there would be uh, different types of disruptions for each of these energy sources based on weather conditions and natural disasters and so on. And then the so for each of these challenges, we will look at little more deeply. So, for example, for the equipment and infrastructure limitation, so your existing equipment and infrastructure may not support any flexible manufacturing practices. So you may have to upgrade or replace or re-engineer that. So it's going to be very costly and time consuming. So this is a huge challenge for achieving flexibility in manufacturing. And then high costs associated with reconfiguring production lines, and as well as you may have to invest in new technologies, and then any other type of financial limitations can prevent from adopting these flexible systems and processes. And then when it comes to customer demand variability, so there are rapid changes in how customer preferences are changing, and as well as rapid changes in the demand, how the demand patterns are varying for specific things. So it is very difficult to predict and respond to these changes when you don't have a very flexible manufacturing facility. So and these demands and these changing preferences becomes a challenge for you to address when you don't have a flexible production facilities. So uh, you should you may have a specific schedule, and then specific timelines, and as and when these are changing, you will not have the ability to maintain flexible production schedules when these demands are happening and these patterns are changing very rapidly. and also shortage of skilled workers who can operate and maintain advanced manufacturing systems to achieve such a high degree of flexibility. So uh, when this is a limitation, then even if you are ready to invest and have a flexible system installed with modern technology and all, if you don't have the workforce that can understand and maintain uh, and make the necessary changes whenever uh, such demands are coming in, then that will be a loss for you, since you will not be able to uh, take advantage of the systems that you have, and you will not be able to uh, be a flexible manufacturing facility for that specific duration. And then the uh, energy source variability. So to meet different sustainability goals, so industries are integrating uh, diversified energy sources into manufacturing process, and but these uh, integrating alone will not do. You will have to do a lot of work on top of it in enabling the systems to dynamically respond to the cost, weather conditions, and then the dynamic demand changes that happen on the energy sources, and several other factors. And this is really challenging to achieve as well. And on top of it, there are different regulatory compliances in terms of direct and indirect carbon emissions. So you need to be mindful of which type of energy source you are consuming, to what degree, and is it keeping your overall carbon footprint under the limit in the end. So uh, being able to determine that fact itself is a real challenge as well. So we'll look at how OPC and OPCUA FX related technologies can help in addressing some of these challenges. So related to equipment and infrastructure limitations, OPCUA and UAFX technologies would allow you to have a very phased manner integration of the uh, technologies and solutions. So a lot of the existing network and security infrastructures and the machinery can be mostly reused. And then when it comes to um, uh, scalability, so OPCA UFX supports different scalable solutions. So this allows the manufacturers to expand their operations without significant overhauls or reconfigurations and re-engineering. So the overall implementation of flexible manufacturing systems will be a little more cost effective with these technologies. So um, there are already successful demonstrations of automating the configuration process of an OPC FX based system during runtime. Okay, so based on the varying production requirements in these demonstrations, the configurations were pushed onto the system during runtime, and then the system all of a sudden would start behaving differently, doing different activities. In addition to that, there are different. There is a way to map implemented OPCA effects of functional entities to specific equipment which has specific capabilities. So imagine where you have multiple equipments with the different supporting capabilities, and you can very easily assign a specific machine in those to switch out during the process based on the dynamic demands that are coming in. So this can be used to increase the overall flexibility of the automation systems. In fact, to some extent, these demos you can see as well on the OPC Foundation booth if you visit any of the trade fairs where OPC Foundation is participating. And the core of that demo is achieved with controller to controller communication of the OPC FX technology. And related to the customer demand variability, OPCUA and OPCUA FX enables adaptive production scheduling by providing real-time data on production status and demand. At each stage, it can capture rich required information to make these decisions by the upper layer, and the data is seamlessly exchanged with those systems through unified information models. So this creates a much better alignment of production schedules with the customer demands, and then the this overall reduces the lead times and improves overall responsiveness of the production system as well. So related to skill gaps, again, OPCUA and UAFX supports different features by providing rich information. This features such as remote process monitoring, condition monitoring, remote diagnostics, even to the device level. So with all of this, it will allow with few skilled workers to manage multiple systems remotely, and the benefit is increased productivity with a few workers overall, and uh, of course the remote management capability as well improves the overall flexibility. When it comes to energy source variability, so OPCUA and OPCFX supports the integration of energy management systems that can monitor and optimize energy usage in real time. Manufacturers can track energy consumption patterns, and then the carbon cost carbon cost associated with the specific energy source, and their how much of the energy consumed from that specific source, based on that estimating carbon costs and identifying any inefficiencies based on the energy consumption patterns, and making necessary adjustments to reduce overall energy costs and improve efficiency. So as well as different predictive maintenance and analytics and dynamic scheduling systems, these type of applications can be enabled with the real-time energy consumption data that is gathered from the field level and exchanged with the upper layers of the automation in making better decisions. So we will look at the three potential use cases again from the flexibility standpoint. automotive manufacturing plant, suppose if a factory implements a large size one type of production, this is where each car is customized to individual customer preferences and specifications, like the seat color, whether it has to be leather or something else, what should be the color of the stitching, and so on, to give some examples. So automated configuration and production planning processes ensures this type of customization orders are met and handled properly. So the ability to produce highly customized products efficiently can be achieved by implementing flexibility and using OPCUA and UFX based technologies, like how we have discussed so far. And then in the pharmaceutical manufacturing, they may need to quickly switch between different drug formulations. This may be related to some regulatory changes on a specific region where their customer base is located. Again, so the OPCA and UFX based solutions enables flexible production scheduling, and most importantly, real-time adjustments to the manufacturing process. So on the fly, you can make real-time adjustments to the manufacturing process, and then integrating this with a continuous quality monitoring and control systems will allow you to quickly adapt to new drug formulations, and you will have enough data to meet any regulatory compliances and changes as well. And food and beverages, from the flexibility standpoint, suppose if a specific food and beverages unit is depending on any seasonal produce and seasonal products. So with the real-time adjustments to the production and production parameters based on seasonal demand, you will be able to achieve that kind of flexibility in the food and beverages production. And with OPCA and UFX based technologies, that is possible. So it enhances the ability to respond any kind of seasonal market trends, and also it helps in optimizing the use of overall resources and reduces the waste. So with this, come to the end of the presentation. Thank you for joining, and we will soon publish information about our part 10 webinar of this series. And don't forget to join the OPCUA FX professionals LinkedIn group, and be up to date on this technology and developments that are happening here. Thank you.